Hello, my name is Sydney Herford, and this is my cell membrane presentation. So first we have a plasma membrane, and a plasma membrane is a membrane made up of lipids and proteins, which form the outside parameters of the cytoplasm and circle around vascules and function to regulate molecules coming in and going out of the cytoplasm. So first we have the sandwich model, which is by Davison and Danieli. And this model was actually incorrect at first. This was adopted in 1935, and that is not the true model we see today because they saw proteins on the outside of the molecule, but it gives us a general idea of what they saw going on. And so then I'm going to go over to the fluid mosaic model, which was by Singer and Nicholson. And we're going to go to the phospholipid bilayer. And the phospholipid bilayer actually has quite a bit of channels or components, as you know, a lot of people would like to think. So we have the ion channel, which is typically a gated ion channel, which is proteins that allow ions to pass through the membrane in response to, you know, chemical messengers or something going on that allows a protein to come through. And then we have the membrane channels, which we have the, and just so you know, that gated ion channel, it just has a gate against it. Ion channel is just a general term for the gated channel. In the membrane channels, we have integral and peripheral. So the integral is attached directly to the bilayer of the proteins, and the peripheral is not. And so the peripheral can come off quite easily, but the integral cannot. And so it's easier to study the proteins that are in the peripheral. And then from the gated ion channel, we go into the concentration gradient. And that is the gradual difference in the concentration of solutes in a solution between, you know, two regions. There's, you know, one side or the other, and that is the concentration between them. And as far as the structure goes, we have the hydrophilic head and the hydrophobic tail. And the hydrophilic head loves water. It's a fluid already, so it binds well with water. And the hydrophilic tail is more like an oil, more scared of water, doesn't want to interact with water. And then we have simple diffusion. And simple diffusion is solutes are moved across gradient over time. It's a very slow process. And then we have osmosis. And osmosis, solution on one side of a membrane is less concentrated than the other, maybe. And so they interact for a while and they eventually become equal. And then the channels based on that are the ion channel, the passive transport, and the detergent molecules. So the ion channel is proteins that are throughout membrane that allow ions to pass in and out of the membrane. That's pretty simple, you know, just cation or an anion is coming in or going out, and they see that molecule and they allow it to come in or out. And then we have the passive transport, and that is the movement of molecular substances and ions across a membrane that doesn't require any energy. So that is very simple. No energy is required, and ions coming in or molecules coming in, something like that. And that is very, I guess, wide open. It's not direct, and that takes a very long time. And then we have the detergent molecules, and these molecules are typically enzymes, and they really break down either a fatty acid or something. That's pretty much what they do, is break down a fatty acid. And so detergents are going to be our main thing as an enzyme, a breaking down of structure, essentially. All right. Now we're going to look at vesicles. And vesicles allow membranes to move from one part of the cell to another. This is part of the endomembrane system. It has a distinct inside and outside. That will never change. It's always going to be very distinct. And then I'm going to go into structure. So we have selective permeability, and that means some things can cross and some things cannot. And so for our phospholipid bilayer, we have an amphiotic molecule, which means that it is hydrophobic and hydrophilic at the same time, depending on which side you're looking at. And so we have glycoproteins, and glycoproteins are mainly proteins with little carbohydrates. They're relatively short oligosaccharides, and then we have glycolipids, which are carbohydrates attached to phospholipids. And then we have polydoglycan, and this is proteins with long polysaccharide chains. And so both of these go into saturated and unsaturated fatty acids. Saturated means that they have carbons that are all bound to something, and so they have no room for hydrogens to come in and take place. And unsaturated means that they have room for hydrogens to come in and take place. All right, then we have permeability, which again is just the structure of the molecule, essentially. It goes to concentration. This is the gradual difference in concentrations of solutes in a solution between two regions. And then we have sterols. And sterols are steroids, and steroids come in between unsaturated and saturated fatty acids to make things more rigid, and this lessens the permeability. But if the phospholipid bilayer is too warm, per se, then it'll use a steroid to not necessarily cool off, but to make things more rigid, thicker, that kind of thing. And then we have gated ion channels, which are a group of transmembrane ion channel proteins that allow ions to pass through a membrane, typically in response to a chemical messenger. And then lastly, we have passive transport, which is the movement of molecules, substances, and ions across a membrane that doesn't require energy input, which I described a little bit before. And thank you for your time. Goodbye.